So with that starting point, we hired up a bunch of consultants from industry who are very tech savvy, as well as a bunch of engineers and whatnot, and enable them to take the information and the learnings that the professors are putting together, and then driving that into industry with clients like Air Canada. So it's pretty unique. We're in that ecosystem with respect to Montreal, like I mentioned earlier. People like Yoshua Benjo is very prominent in that space, but there's a whole community around him that are just as good, and which is great for us in the sense that not as popular, so then we get access to them. So having that benefit and that advantage really is important for us. And just FYI, this is the rest of the team that helped us with respect to this project. So as we go through it, this is the folks who cut their teeth in that whole thing. So what's important with respect to Vidal Labs is we're definitely not dogmatic about how we approach artificial intelligence. So we're very practical about how we do about it, because what matters is getting results, not necessarily the techniques. So obviously deep learning gets all the notoriety and press, but we definitely take the entire spectrum of what's possible and apply that relative to the problem at hand. So we definitely focus on what is that root of the problem, and we start there with respect to our clients. So where are their problem sets, where they're within the process, what is really holding things up, where are they having problems hiring or firing people and things like that. And we break that down into an algorithmic framework. So what do I mean by that is essentially, and there's this really good course in actually Lausanne in Switzerland that they take a lot of their business analysts through and people who do their engineering courses. And it's called computational thinking. And essentially what we do, and similar in that fashion, is we take a business process and then we'll break it down into kind of this algorithmic framework, and then therefore you can start mapping technologies against that, right? So we're reframing business processes into this computational framework that allows it to then be codified to a certain degree. And then what we do is then apply the appropriate machine learning and or AI technology around it. So when I say the different types that we use, we do have very much experts across the whole spectrum. So we have people who are part of MILA, which is one of the major institutes around machine learning that are very good in autoencoders, deep learning methods, and all that. But also one of our main professors, Andrea Lodi, he is one of the world leading researchers on real-time decision making and operations research. And so we combine a lot of those methods and then use them together to then solve real-world problems. And then finally, what we do make sure is once we've implemented the solution, how do you design an experiment such that you're confirming the value that it's bringing to you? So obviously we do the business cases as well, but really in terms of making sure that people are accepting it, that you can measure the results in a tangible way, we actually use scientific method to make sure that we can do that with our clients as well. And so that's a very important step with respect to our deployment and how we implement these solutions in the real world. And then finally, with respect to Ivado Labs and Air Canada, I'll let Wayne take it away with respect to Air Canada and their ambitions around artificial intelligence.
Thank you very much. So thank you for your time, guys. So we're here to represent Canada. That's why we're here. So at Air Canada, pretty much we have a very ambitious kind of goal that we have. We want to be a top 10 airline in the world in the next 5 years. Also in Canada, we want to be the kind of employer of choice for people who are doing advanced analytics. We're talking about machine learning, deep learning, optimization, things like that. So how are we doing that? There's a couple of ways that we can get there. One of the things we want to do, we want to use AI for sure to make sure we get there. So what we've done is establish a center of excellence around AI. We are starting to hire top talent to make sure they come and work for us. At the same time, we start doing partnerships to make sure that we've got the right people working, helping us to solve our business problems. So Ivado Labs is one of those partners that we have that are giving us that kind of strength to do the project we want to do. We just finished a kind of our AI strategy last year, which is a 3-year roadmap of how we want to achieve this across our operations. If you can go to the next slide. So one of the things we did find is that data is actually the key to doing proper AI. So if you look at this cycle that we have here, we say, okay, having good data makes us make better decisions. So one of the things we're using, if you look at the cycle, we can do better analytics using data. So we don't like the word AI and A cannot that much. We want to use the word advanced analytics. That's the proper word we want to use. So from there, we can actually get better insights of how we can make better decisions in terms of our operations, in terms of how we serve our customers, in terms of how we buy better planes, things like that. Then from there, we can actually drive more kind of customer service for ourselves and get more customers for our business and retain our customers. And that in turn creates more data. So if you look at this, really we say data is kind of the fuel that drives this engine all around it. And that's kind of the focus where we are. So the bottom line is that data is an asset that we have. We treat data just the same way we treat a 787. It's an asset. Go next slide. So as I said, we did a number of use cases last year. The use case I want to talk about today, if you look at the team here, is talk about how do we increase demand forecasting for our business. The biggest problem is passengers come, we want to understand the spikes. We understand when the passengers can show up. There are so many stochastic events that happen in the market. So how can we actually increase the accuracy for that? So that was the use case that we're working on, and the team here did a good job. We want to share some of the results with you today. If you look at the problem, it's a very complex problem. Air Canada is now pretty much an airline, an international airline. We just increased our international routes quite a bit. So if you talk about the problem, we're talking about over 100,000 origin and destination pairs that we have to work with. So that's a very extensive network. We talk about 100 demand managers that work day in, day out, try to understand, of course, the demand in the network. And we have to look about 355 days ahead of schedule. So we're trying to focus pretty much a year out, right? And of course, we've got so many unforeseen things that happen in the world. The 737 MAX issue, a geopolitical issue that happen across the world. So there's so many things that happen that we need to understand. So if Arnold was talking about the process, that's pretty much what we're trying to solve next.
And then in terms of, one important thing when we were trying to understand the problem itself, I mean, this was a problem statement that Air Canada presented to us. But from our perspective, obviously, we're machine learning experts. This is not our day in and day out kind of job. But with the model that we have with respect to that consulting mindset, we worked closely with the demand managers up front in terms of really understanding how they do their job today and weaving that into our solution. So we were not blind in terms of just applying the math to the data, right? We really tried to understand how they do it today, what were the roadblocks they're facing, and also kind of pulling out any kind of insights they had that actually, quite frankly, is not within the data itself, because the data just can tell you what's there, and you're limited, and the machine learning models will be limited to what's available in the data. So what we wanted to understand are what other information and what other insights those demand managers use to make their decisions as well. And so then that helped us understand the limits and the possibilities that we could achieve with the machine learning models. So that was very important, and that helped set expectations significantly with respect to what is possible and what can be done for those demand managers. So in terms of the actual solutioning itself, I mean, we tried a host of different methods just to provide a baseline at first, but as well as to get a viewpoint on the art of the possible with respect to applying more advanced techniques. So tree-based methods, very popular, obviously, and they did perform quite well. But also some interesting ones around autoencoders, deep learning-based autoencoders, which our team is very familiar with, that use in very many different scenarios, particularly good for time series forecasting. So we applied it in that sense as well. And the reason why we did that, which I think is, for a lot of practitioners is very obvious, but what was important for the client as well as the demand managers itself, and more so the executives, is understanding and helping educate them about the technology itself, in a sense, and that idea about explainability versus performance, right? So trusting the system and understanding what information it's trying to tell you, and understanding those factors that are driving that decision is obviously very important for a lot of these people. I mean, at the end of the day, we are touching a very significant part of the business. And when I say that, it represents roughly $14 billion worth of revenue for Air Canada every year. So we're just not going to blindly throw a machine learning model in there and see what happens. So when we're doing historical backtesting, we use these different models to help the executives and the teams really understand in depth what these machine learning models are doing in terms of performance, how they perform, but also the level of explainability that is possible with these different methods. And so that allows the audience and the actual users to gauge how much they want to achieve with respect to how much they can understand on how these things are operating, right? So that's important. And also another aspect in terms of how we deploy our solutions, because again, we're a bespoke, we build custom solutions for our clients. One interesting thing is, and a benefit of that approach, is that we integrate with existing systems. So Air Canada obviously has a very extensive technology footprint with respect to how the business is operated. There are reservation systems, there are already various demand forecasting pieces inside there. And so what we're doing is adding machine learning or adding AI within that environment and complementing those systems and enhancing them, right? So we're not about replacing things, because that in itself is already a journey. So because we're trying to make impact relatively quick and drive that value, we look to opportunities to insert the AI solutions within that existing technology framework. So we're very surgical about how we do it. So both from a process perspective in terms of what we're attacking and how we're looking at that different points within the process, where do we apply AI? And then from a technology landscape, where exactly can we complement the existing technology such that we're not disrupting the entire environment? Because that alone, if we do an entirely new platform and just completely replace some major technologies in there, that alone will just kind of set us back, quite frankly, a while back, and then Air Canada will have another project ahead of what needs to get done. So that was a very important thing. And lastly, I will say is human in the loop, for sure. As I said earlier, the demand managers themselves, the whole team, were very critical in terms of helping design a solution. And I think what ends up happening is that trust factor builds rather nicely throughout the project. So trust obviously is a very big topic. I was just talking on Monday at a big hedge fund conference, and that was the big topic of the day. It's how do we trust these algorithms? If you have your audience and your actual end users participating within the building of that algorithm, even though they may fully understand every aspect of it, they're still participating. And as they participate and see the results, whether they're good or bad, that helps them understand a little more about what's going on, and also it gives them confidence, and the whole team confidence, that to a certain extent we are inserting some of that knowledge that those people have into these algorithms. So then therefore, to a certain extent, if it behaves quite oddly, we can just point back to, well, we were all a team and we all did this together. So it gives ownership to that whole process itself, which I think is very important. And then in terms of how we measured value, I mean, impact generated on revenue, market, and the human users. Obviously, we're going down that path now. So, what's interesting here is, I think, next slide.
Yeah, if you can go back to the other slide.
Oh, you want to?
Yeah, a couple of things here. Yeah. I think the last point you have there, human in the loop, was key for us there, was we wanted to make sure that if we build a model, we can explain it. So we do want to have a black box. We wanted to make sure that we can see the results, we can speak to them, we can see exactly what's happening. One of the key things we did find is that 40% of the time we spend building models, trying to solve the problem, but 60% of the time you are doing change management. So change management was huge for us. We had to ensure that we've got the business users involved from the beginning to the end. We're now going to the next phase of the project, which is really now engaging the business users to buy into the process, to buy into what we're trying to build. So if you look at the end result there, so the way we do work at Air Canada is that we start with a business problem, like Arnold said, then we create what we call a lab. So a lab pretty much takes about 12 to 16 weeks to do, and we put a team together. And their goal is pretty much to work as hard as they can. They've got, of course, runway to fail. If they fail, that's fine. Is really to try to solve that problem as quickly as possible within 12 to 16 weeks. So within that lab time, our goal is to produce a POV, which is kind of a proof of value, which can be kind of deployed to production. Actually, I wanted to say MVP, which is a minimum viable product. So once we have this product, then we can then deploy it to a subset of our market. We can test it, validate that the solution is working. We can prove the value of that solution. Then once we have that, we then scale the solution now across the network that we do. So that's how we operate pretty much at Air Canada. So if the number you see there, this is the first kind of, for this use case, which is demand forecasting, we selected a few origin destinations in our network, and we did a couple of models, and we actually worked with the demand managers to see the impact of the models to our volume and our demand. And we're looking around 25% kind of model accuracy improvements in the work we're doing, which is a big number. Unfortunately, I cannot share actually the impact of revenue here, but it's a big number. What we're going to do now is take these models now, we're going to start scaling them now across the organization, and that's where change management comes into play. So the way we look at AI, pretty much we try to take it in a very pragmatic approach, small baby steps as we go, but at the same time impacting the business as we go forward. Yeah.
So keys to success, and this is just reiterating what I had mentioned earlier, but involve the users early, obviously. Again, one key mandate we have at Ivado Labs and part of our operating model is actually integrating with the client's delivery teams and actually the extended teams as well involved in the project. So, one interesting thing that we are doing with Air Canada is co-locating. So part of their AI team will be co-locating with us, and we have these sort of separated almost mini offices within our office that have separate tabs. So the clients that we do work with co-locate some of their AI teams within our group so that we have that joint kind of ownership of the projects, and we feel like we're very much integrated in terms of working together. So that's sort of the model that we use at Ivado Labs. And the reason being is our real motivation is to empower our clients to then take on these solutions moving forward, right? So we're not there as a typical consulting shop like where I came from in terms of PwC or Deloitte or the other kind of big fours, where they sort of get in there and they kind of stick around and then they're kind of forever with you. I mean, we're forever with our clients in a different way, in a partnership where Ivado Labs is always looking to do the edge cases and the more challenging ones. And then as we're going through that journey, then more AI assets are developed, and the bulk of those AI assets are actually then carried by the client themselves, right? So we don't want to carry that entire load. So really it's important that we involve the users both from the end user perspective, but actually from the implementation team as well. Experiment and iterate. So as you can see, we tried a few models. We were just going around trying to see what made sense. We had obviously certain hypotheses about what we're going to perform better or not, but we have to prove those results because it's a function of the data itself and what we can do with the people. So we went through very quick iterations in terms of delivering these models, putting them together. Even though they weren't perfect, we would always run that through the data and then show those results incrementally with our client. And then that helped everybody readjust really quickly. And then finally, testing in the real world. I think we just don't do back testing. So right today, we're actually doing it with respect to some real live data feeds. And so one important thing, and we're doing this with another client as well, is today, some of our models are actually pushing out gas prices at Circle K gas stations as well. So, it's not really pushing a button, but the model's running every so often, and the gas price you see on the pump is changing because of our models. So we definitely are about industrializing these solutions and integrating it within a technology framework such that we can see the real outcomes and actually measure that behavior of the environment relative to what we're doing. Because as soon as you perturb that environment, historical tests are fine, but that's history, right? Once you actually put this model in the wild, see what happens, then you get the real results in terms of what it is you're trying to achieve. And that's the interesting thing we've been doing at Vidal Labs, which is exciting, and why we've been able to sort of get traction with a lot of clients, is that we iterate, we go really focused on the type of solutions we'll do, and then we can put them into production. That's always our end game. It's not about what happened, how did it measure up in the past. It's what's going to happen, and together we're going to measure scientifically how it's affecting your future, right? And that's about it. We'll probably open it up to some questions if anybody has any. I know we're a little quick, but you know the message is pretty straightforward here. Any questions? Ah, there.
How big are the teams?
Yeah. So we have a big team. So we just have a center of excellence within Ekana that we have built together. But depending on the lab, a lab is typically about 10 to 12 team members in the lab. So you're looking maybe 2 data scientists, 2 data engineers, a scrum master, a product owner, you know, a business translator, the person that connects the team to the business, and a change manager. So your team depends on the problem or use case you're working on. Because if you're working on an optimization problem, that means you need to bring some OR people, you know, if you're, you know, depending on the solution you're building. So we see somewhere between 10 to 12 people working in a Scrum team for that lab. Then once the lab solution is finished, it goes to our factory team, which is now going to put that solution into production. And that team can also vary depending on how you're going to deploy the solution in the real world.
Yeah, and one thing driving the size of the team is not only obviously the complexity of the solution, but what we do is define the features within that particular MVP scope and time box it, right? So we try to say, look, we want to deploy something within about 4 to 6 months. And that's where we start almost. And then based on that time frame, what is it can we do, right? Because what we're trying to do is prove it out. I mean, there's a lot of talk, obviously, we're here at CogX, and a lot of talk about AI, but we're here to see really and prove it. And that's what we get challenged by the executives, right? The executives are like, I've read this in WSJ, The Economist, you know, it sounds great. Somebody show me something. And so we're all about that. And so we just time box it. We go, okay, we'll do something in 6 months. I don't exactly know what we're going to do in 6 months, but we sit down with the client, and then we do it with the technical teams. Here's exactly what we can do once we define that problem. And so that's the way we approach it, right? It's just time box it, get it out there, and then incrementally add your features as you go along. But it's important that way.
You talked about improving performance by 25%. What does that mean?
Yeah, it means quite a bit. So the way we look at each project, we look at what's the impact to the EBITDA, to our revenue. That's what we're looking at. So we say, okay, we have existing models today that we use, that have been built in-house already. So we want to improve accuracy by setting margin. So when we start a project, we actually see this is the baseline that we have, and this target we want to get to. So once we go to a testing phase, we create a control group of the areas that we want to focus on, and we start measuring that. So everything we deploy is actually measured according to the KPIs that we established at the beginning of the project.
And those KPIs are revenue-based?
Most of them are revenue-based. Some of them are based on different kind of priorities in the organization. We've got non-revenue and revenue-based KPIs that we have. Then we have a weighting in terms of what's more important at that time.
Yeah, that 25% was not 25% in revenue. I can tell you that.
Yes. Yeah.
You talked about involving the end users within the process. Can you share what type of techniques or exercises you do with them to best extract what you need?
Yeah, so, I mean, even Jack can speak to this. I mean, he was part of the whole thing. But a lot of it is, I would say, change management or design thinking type methods, where you involve them, you sort of do those interview-based kind of approaches. That's what, you know, coming from the strategy firms, we're very familiar with. And they work very effectively in that sense. But I would say that's kind of the general approach. Cool? And it's blinking now.
Thank you for your time.
All right, thank you very much.